Dear young learners, in the previous class we were studied about the calculation of pH of a stronger acids. Now in the present class, in the today's class, we are going to learn about the calculation of pOH of a stronger base. You know what are all called stronger bases? The bases which are completely dissociated in their solution, and to form the positive ion and in particular negative OH minus ions. So what are all the bases which are forming the positive ion and the hydroxide ions in their solution? Completely, when they are dissociated, we can call them as stronger base. For such kind of stronger bases, how to find the pOH value? The pOH value is nothing but minus logarithm of hydroxyl ion concentration to the base 10. pH was hydronium ion or hydrogen plus ion, but at present pOH, it is the negative logarithm of hydroxide ion concentration to the base 10. And how to calculate the hydroxide ion concentration? Just it is equal to the normality of given base, stronger base. Suppose instead of that, for your calculations, if you are given the molarity, better you multiply that by acidity of given base. What do you mean by acidity? It is nothing but number of replaceable hydroxyl groups. Consider this base NaOH. It contains only one OH and hence its acidity is equal to 1. So for all your monoacidic bases, you need not bother about the normality and molarity. The given normality might be equal to its molarity because the reason acidity is equal to 1. But when a base is given like this, calcium hydroxide, just see, this can be dissociated to form Ca2 plus and 2 times OH minus. So here the acidity value should be taken as 2 replaceable hydroxyl ions. Then its OH must be taken as follows, that is equal to the molarity is to be multiplied by 2 because its acidity value is equal to 2. Suppose if you are given the aluminium hydroxide AlOH thrice, this can be dissociated into Al3 plus and 3 times OH minus. Then how do you calculate its hydroxyl ion concentration? That is equal to the molarity. It is to be multiplied by 3 because it has got 3 replaceable hydroxyl group and it is due to the acidity. Acidity value for the given base is equal to 3. So we will do some sample problem for the calculation of pOH of a bases like this, in particular stronger bases. See the example problem, and in order to calculate the pOH of a stronger base. This is a sample question you are given. Calculate the pOH of 0.001 m AlOH thrice solution. It means aluminium hydroxide solution you are given. So it's a stronger base. For that, how do you get the hydroxide ion concentration? We have already studied that molarity is provided means it is to be multiplied by acidity. Here the acidity of the base is 3. It has got 3 replaceable hydroxyl groups. And the molarity is provided as 0.001 and acidity is 3. So that we can write 0.003. This is equal to 3 into 10 power minus 3. And to calculate the pOH that is equal to minus logarithm of hydroxyl ion concentration. I can write minus log of 3 into 10 power minus 3. Yes, this can be written as follows. Minus, and I am splitting this, log of 3 plus log of 10 power minus 3. And minus log of 10 power minus 3 is written as follows, minus 3 into log 10. And log of 3 is 0.4770. 0.4770, otherwise it might be equal to 0.4771 exactly. So that we can write minus, and log of 10 is 1 plus 0.4771. When the minus sign is taken into the bracket, 3 minus 0.4771. And the answer will become equal to, the result of this is equal to 2.5229. That should be the answer for this. When we add these two, 2.5229 and 0.4771, that will become equal to 3. And hence we are getting a pOH value for the given base in this manner. Is it clear? Yes. Hello dear young learners, and in today's class we are going to talk about the calculation of pH for weaker acids and weaker bases. When the electrolyte is weaker, we are not using the regular method of calculating the hydrogen ion concentration. For stronger acids, the normality is treated as its hydrogen ion concentration. Molarity means it is multiplied by basicity. But in the case of weaker electrolytes, when it is a weaker acid, this is a way of calculating the pH. pH of weaker acids. How to calculate? We know very well about the pH. pH is nothing but minus logarithm of hydronium ion concentration or hydrogen ion concentration to the base 10. And how do you get the hydronium ion concentration? Hydronium ion concentration, H3O plus, that is really equal to the hydrogen plus, that is equal to C into alpha, where C is the concentration of given weaker acid, alpha is the degree of dissociation. So if you know the concentration and the degree of dissociation, you can calculate the hydrogen ion concentration. This is one way. And one more idea, the hydrogen ion concentration for a weaker acid can be given as follows, the square root of Ka into C, where what is called Ka? It is nothing but dissociation constant of given weaker acid. So by using this relationship, C into alpha or the square root of Ka into C, where the C is nothing but the concentration. It might be the normality or molarity. So this is the idea by which we can get the hydrogen ion concentration. Suppose for a weaker base, in order to calculate its pOH, the hydroxide ion concentration, OH minus ion concentration, that is equal to C into alpha. Or we can say the hydroxide ion concentration for a weaker base, that would be the square root of Kb into C, where what is called Kb? Kb is nothing but dissociation constant of given weaker base. Yes, if you are given the Kb value, that can be multiplied with the concentration of the base. So this is the way by which we can get the hydroxyl ion concentration for a weaker base. Why we are calculating the hydroxide ion concentration? Because pOH that is equal to minus logarithm of OH minus ion concentration to the base chain. So it's a slight comparison in between the calculation of pH of weaker acid and pOH of weaker base. To calculate the pH, we should know the hydrogen ion concentration. It is nothing but C into alpha. And in order to know the pOH of a weaker base, you should be provided with the hydroxyl ion concentration, that is C into alpha, where C is concentration and alpha is the degree of dissociation. And what about Kb? Kb is nothing but a dissociation constant of given weaker base. If it is given, that can be multiplied by the concentration. When you take the square root of that, you will be getting the hydroxyl ion concentration. With the help of that, you can calculate the pOH. Okay, and we will do some problems by using these two equations or by using these relationships. And hello students, you just see, you are given an example to calculate the pH of a weaker acid. Calculate the pH of 0.1 m CH3COOH solution, acetic acid solution. The dissociation constant is provided to you. It is given as 1.8 into 10 power minus 5. So how to calculate the hydrogen ion concentration? We know that the hydrogen ion concentration of a weaker acid, namely the acetic acid, yes, it can be done as follows. That is equal to C into alpha, one formula, and one more formula is the square root of Ka into C. Here we are going to use this particular formula because you are given the concentration as well as the dissociation constant. So based on that, this is equal to the square root of Ka is given as 1.8 into 10 power minus 5 and the concentration is 10 power minus 1. Why I am writing like this? Because 0.1 is nothing but 10 power minus 1. The concentration is given as 0.1 m. So if you multiply these two, you can get 1.8 into 10 power minus 6. On taking the square root, it's a fixed value. Normally you might be given the square root of this. It is equal to 1.34 into 10 power minus 3. Now the hydrogen ion concentration is ready. Then the next step is very simple. We can do the pH. pH that is equal to minus logarithm of hydronium or hydrogen ion concentration to the base chain. Hydrogen ion concentration is provided here. So I can write minus logarithm of 1.34 into 10 power minus 3. This can be done as follows. Minus, I am splitting this one, log of 10 power minus 3 plus log of 1.34. And this can be done as follows. Minus 3 into log 10. And the value of log of 1.34 is 0.1279. Otherwise it might be equal to 0.1271. And now we can write this as minus 3 into log 10 is equal to 1 plus 0.1271. When the minus is taken into the bracket, it becomes 3 minus 0.1271. So that becomes equal to 2.8729. This should be the pH of given solution. A very simple idea. You are given the concentration and the dissociation constant. It is applicable for all your weaker acids. The acetic acid is a weaker acid, an organic acid. And this is the way of calculating its pH. Is it clear? Likewise, when you are given the base, weaker base, the same procedure can be followed. And where the weaker base might be the ammonium hydroxide. Sometimes you might be given ammonium hydroxide. And for which how to calculate the hydroxyl ion concentration, use the same idea, the square root of Kb into C. You might be provided the Kb value, follow the same procedure and try to get the pOH value. So this is a way of calculating pH of a weaker acid and as well as pOH of a weaker base. Is it clear?